Marcus, plug me in.
Alright, there seems to be a problem within the matrix development section. It requires dual passwords.
Well, have you known a password?
No, but it can be obtained by solving this problem.
What is it?
Find the direction and magnitude of this vector, 3, 4. Hold up, I got this.
This is a vector. This vector have a direction and a specific length. Magnitude, length, and direction angle is the two main characteristics of a vector. Here, a vector with an angle of 130 and a magnitude of 2. And here is a vector with an angle of 70 and a magnitude of 3. Now let's take a look at vector A. There's actually two ways to represent a vector. One is through magnitude and direction. The other is through component form. A represents a natural horizontal unit that the vector travels. B represents the vertical unit. Here are the two ways. Now, here is how you interchange between the two types. You can see the vector form a right triangle if you were given theta and you were given a magnitude or hypotenuse d. Then you can use it to find the component form. Using the shortcut, the horizontal component is d cos theta. The vertical component is d sine theta. Keep in mind that you must know your triangle trig properties to understand this shortcut. Next, if you were given a and b, then you could use the Pythagorean theorem to solve for c, the magnitude, and then you could solve for theta, the angle with tan function. So for this example, we are given a vector with a component of 3, 4. Let's find the magnitude and direction. First, we must draw a vector. You know that we go 3 to the right and 4 up. Now you have your vector. This vector also formed a right triangle with legs of 3 and 4. So find d, the magnitude, so we could use the Pythagorean theorem. D squared equals 3 squared plus 4 squared. D squared equals 25. D, the magnitude, is 5. Now to find theta, the direction of the vector, we know that tan theta is equal to 4 over 3. And theta is arctan 4 over 3. Using the calculator, we could get theta equal to 53.13 degrees. And this is our direction.
Neo, welcome to the matrix. Welcome. Here, the matrix mimics reality with the same basic principles of wind and gravity. This is a combat training program. Here, we will prepare ourselves for a fight against the matrix. Let us test your marksmanship. Take out those targets.
I missed.
That is because you forgot to factor in the wind.
Okay, let's say that you are standing here and this is your target. You shoot a bullet at a rate of 900 meters per second, and the wind is pushing on it eastward at a rate of 27 meters per second. As you can see, the wind is acting on the bullet, creating a new path for the bullet, which is also the net force of the two vectors. So to find the net force of the vectors, we need to add them together, connecting them. Now remember, when you are connecting vectors, you must connect the endpoint of one vector to the initial point of the second vector. You cannot connect it like the examples below. Remember, only endpoint to initial point. So knowing that, let's go back to the problem. We connect the two vectors by transferring the wind vector connected to the end of the bullet vector. This will generate the resultant vector, the new vector of our bullet. Okay, so now to find the speed of your bullet, we can use the Pythagorean theorem because it formed a right triangle. 900 squared plus 27 squared equals d squared. If you solve for d, you get d equals 900.40 meters per second. That's the speed of the bullet and the magnitude of our vector. Now to find the degrees that your bullet are off by, we solve for theta. You know that the tan theta is equal to 27 over 900. Theta equals arctan of 27 over 900. Thus theta equals 1.718 degrees. This is the direction of the bullet.